In this video, we're going to solve the October-November 2023 question paper 12 for the CIE A Level Maths 9709 exam board. If you like my past paper breakdowns, subscribe and let's get into it. Number 1. The coefficient of x cubed in the expansion of 3 plus 2ax to the power 5 is 6 times the coefficient of x squared in the expansion of 2 plus x to the power 6. Find the value of the constant a. Okay, let's start with the expansion of 3 plus 2ax to the power 5, and we want the coefficient of x cubed. Okay, so that means this 2ax should be raised to the power 3. So we're going to have 2ax to the power 3, which would mean that this 3 should be raised to the power 2. So that our powers add up to 5. And then we know that n choose would be 5 choose, and then this number at the bottom here will be the same as this number over here. So that will be 5 choose 3, and we can simplify that. 5 choose 3 is 10, times 3 squared, which is 9, times 2 cubed is 8, a cubed, x cubed, and this will simplify to as 10 times 9, which is 90, and then 90 times 8, which is 720, a cubed, x cubed. So that's the coefficient. The coefficient of x cubed in our expansion of 3 plus 2ax to the power 5 is 720, a cubed. Now let's find the coefficient of x squared in the expansion of 2 plus ax to the power 6. So that's 2 plus ax to the power 6. To get x squared, this term here must be raised to the power 2. So this will be to the power 2, and our powers are supposed to add up to 6. So the 2 should be raised to the power 4. And then that means 6 choose, and the bottom number will be that power over there. 6 choose 2. And 6 choose 2 is 6 choose 2, that's 15, times 2 to the power 4, which is 16, times a squared, x squared. So that's 15 by 16. We get 240, a squared, x squared. So they say the coefficient of x cubed, which is 720a cubed, is equal to 6 times the coefficient of x squared, which is 240a squared. So this is times 240a squared. Let's simplify that. That 720a cubed is equal to 6 times 240, which gives us 1440a squared. And we want a, so we're going to divide both sides by 720a squared. So a is equal to 1440 a squared over 720 a squared. So a would be equal to, this is 1440 divided by 720, which is 2. And so our final answer would be a is equal to 2. Question number 2. Find the exact solution of the equation 1 over 6 pi plus arctan of 4x is equal to minus arc cos of half root 3. Okay, so let's evaluate what negative arc cos of half root 3 is. So we have, this is for x is equal to, if we punch negative arc cos, make sure that you are in radians. Negative arc cos of half root 3 That gives us negative 1 over 6 pi, negative 1 over 6 pi. Okay, and so now our goal would be to make the x in 4x the subject of the formula. So what we can do is to say arctan of 4x is equal to negative 1 over 6 pi. We move this to the other side, it becomes negative 1 over 6 pi. And so you've got arctan of 4x is equal to negative 2 over 6 pi, which we can write as negative 1 over 3 pi. And then this becomes 4x is equal to tan negative 1 over 3 pi. And if we evaluate tan of negative 1 over 3 pi, we get tan negative 1 over 3 pi is equal to negative root 3. So 4x is equal to negative root 3. Divide both sides by 4, you get x is equal to negative root 3 over 4. And this would be our final answer. Question number 3. The equation of a curve is such that dy dx is equal to half x plus 72 over x to the power 4. The curve passes through the point P to 8. Find the equation of the normal to the curve at P. Okay, so we're given the gradient function dy dx, so we can use that function to find the gradient of the tangent at the point P, or when x is equal to 2. So let's substitute x is equal to 2 into dy dx. That would become half times x, which is 2, plus 72 over 2 to the power 4. If you punch that into the calculator, you get, this is 1 over 2 times 2 plus 72 over 2 to the power 4. That gives us 11 over 2. So it means the gradient of the tangent is 11 over 2. Now we want the gradient of the normal. So that's the negative reciprocal of this fraction. So that's negative 2 over 11. And we're given the point P to 8. So now we're going to use y equals mx plus c to find our equation. So our y value is 8. And then our gradient is negative 2 over 11 multiplied by x, which is 2, plus c. So this becomes 8 is equal to negative 4 over 11 plus c. So c is equal to 8 plus 4 over 11. C is equal to, punch that into the calculator, that's 8 plus 4 over 11, 92 over 11. 92 over 11. So therefore the equation of the normal would be y is equal to negative 2 over 11x plus 92 over 11. Part B, find the equation of the curve. Okay, so we have dy dx, and that's half x. I'm going to bring the x to the power 4 to the top, so it becomes 72x to the power minus 4. And we also have the point P to 8. Okay. So to get the equation of the curve, we have to integrate our gradient function. So that would become y is equal to, if you integrate half x, you get 1 over 2 times 2, x to the power 2. Plus 72, if you raise minus 4 plus 1 is minus 3. So that's 72x minus 3 over minus 3 plus our constant of integration. So y is equal to a quarter x squared, and then 72 over negative 3. That's negative 24. So you get minus 24 over x to the power 3 plus the constant of integration. Now let's substitute x equals 2 and y equals 8 into this equation so that we can evaluate c. So y will be 8, and this is a quarter, times 2 squared minus 24 over x cubed, which is 2 cubed, plus our constant. So that's 8 is equal to, this is a quarter times 4, so that's 1 minus 24 over 8, which is minus 3, plus our constant, so that's 8 is equal to minus 2 plus c, so c must be equal to 10. So therefore the equation of our curve is y is equal to a quarter x squared minus 24 over x cubed plus 10. And that's our final answer. Number 4. The diagram shows the shape of a coin. The three arcs AB, BC, and CA are parts of the circles with centers C, A, and B respectively. ABC is an equilateral triangle with sides of length 2 centimeters. Find the perimeter of the coin. Okay, so let's start with the arc AB. We've got our arc AB over here. And arc AB is coming from a circle with center C. So if I'm to complete this, that's our radius from our center to A, and then from the center to B. As you can see, our arc here has got a radius of 2 centimeters, and we're told that ABC is an equilateral triangle. So this would mean that this would be 120 degrees, or in other words, pi over 3 radians. We'll come back to that. And now they want us to find the perimeter of the coin. So the perimeter in this case would be arc AB plus arc BC plus arc AC. And so since triangle ABC is an equilateral triangle, it would mean that all three arcs are of equal length. So we can simply write our perimeter as 3 times arc AB. So now let's use the formula for arc length. It's I theta. So our radius is 2 and our theta is pi over 3. So you end up with a perimeter of 2 pi as the final answer. Part B. Find the area of the face ABC of the coin, giving the answer in terms of pi and root 3. Okay, so they want us to find the area of this whole coin. Okay, so let me just draw these dotted lines over here. Like that. And you notice that we have these segments over here. We have 3 of these segments, right? And each segment is equal in area to the other segment. And then we have a triangle in the middle, that's triangle ABC. So if we want the area of ABC, we're going to have to find the area of the 3 segments plus the area of the triangle ABC. So to find the area of a segment, what we're going to do is we're going to say, notice how the segment would be the sector ABC, sector ABC, right? Minus the triangle in the middle. That will give us the segment that we want. So we're saying area of segment would be equal to sector area minus area of triangle ABC, right? So let's start by finding our sector area. Our formula for sector area is half r squared theta. R squared is 2 squared, and then theta is a third pi. And then we can also find the area of our triangle, and we're going to use half AB. In this case, A and B would be 2 times 2 sine C. It's an equilateral triangle, so all the angles would be a third pi. And now let's simplify. So we've got half times 2 squared times 1 over 3. So we've got 2/3 pi minus then the area of the triangle. So that's half times 4 times sine of a third pi, and that gives us root 3. So the area of the segment would be 2 over 3 pi minus root 3. And now we need the area of the triangle in the middle. So we've already calculated the area of the triangle. So now our final answer, if I can go back to blue, we're saying the area of ABC, of face ABC, is equal to the area of the segment plus the area of the triangle ABC. So that would be 2 over 3 pi minus root 3. Oh, and remember that we have 3 of these segments. So we have to multiply our answer by 3. So this will be times 3 plus the area of triangle ABC. So that would be plus root 3. We can simplify this 2/3 pi times 3 would give us 2 pi, and then minus 3 root 3 plus root 3, and so we have 2 pi minus 2 root 3, and this would be the area of face ABC, and that's the final answer. Okay, question number 5. The first, second, and third terms of a geometric progression are sine theta, cos theta, and 2 minus sine theta respectively, where theta radians is an acute angle. Find the value of theta. Okay, so we have the first, second, and third terms of a GP, and we want theta. What we can do, we can say the second term, if we use the nth term formula, can be written as AR, and we have the first term sine theta. So AR over A would give us R, or we could say the third term over the second term, which is AR squared over AR. This would also simplify to give R. So now what we can actually do is to say cos theta, which is the second term, over the first term, A sine theta, is equal to the third term, 2 minus sine theta, over the second term, cos theta. And then now let's cross multiply. You get cos squared theta is equal to sine theta times 2 minus sine theta. And let's expand our bracket on the right hand side. It's 2 sine theta minus sine squared theta. Now we can rewrite cos squared theta as 1 minus sine squared theta is equal to 2 sine theta minus sine squared theta. And now let's put everything on one side. So 2 sine theta minus sine squared theta. Move this minus sine squared theta to the right hand side. It becomes plus sine squared theta. And the 1 becomes negative 1. And this is all equal to 0. So these two cancel out and you have 2 sine theta minus 1 is equal to 0. So you get sine theta is equal to a half, and theta is equal to arc sine of 1 over 2. Punch that into your calculator, and we've got arc sine of 1 over 2. That gives us 1 over 6 pi, and that's our final answer. Part B. Using this value of theta, find the sum of the first 10 terms of the progression. Give the answer in the form b over root c minus 1, where b and c are integers to be found. Okay, so a was equal to, let's just go back and check. Our first term was sine theta, okay? And we also need an equation to find r, so we can find r by saying cos theta over sine theta. So a is sine theta, and we have r is equal to cos theta over sine theta. And we're given that theta, which we evaluated in part A, is 1 over 6 pi. So that means A is equal to sine 1 over 6 pi. A is equal to, punch that into your calculator, sine 1 over 6 pi, which gives us half. And then R is equal to cos of 1 over 6 pi over sine of 1 over 6 pi. And if we simplify this, that's cos 1 over 6 pi over sine 1 over 6 pi, and that gives us root 3. Okay, so now we want the sum of the first 10 terms of the progression. So that's half times 1 minus root 3 to the power 10, and this is all over 1 minus root 3. Okay, so now we have to simplify to get to the form b over root c minus 1. So let's simplify the numerator first. So that's half. 1 minus root 3 to the power 10 can be written as 243. So you've got 1 minus 243, and this is all over 1 minus root 3. And if you simplify further, you're getting half times 1 minus 243. That's negative 121 in the numerator. Negative 121 over 1 minus root 3. So now we want to get root c minus 1 in our denominator. So the root c is positive, so it means we have to factor out a negative sign for our root 3 to become positive. So what we have here would be negative 121. You factor out a negative sign, you get negative 1 plus root 3, and these negative signs cancel out, and you've got 121, and we're going to write the root 3 first. Root 3 minus 1, and this would be our final answer. Number 6. The equation of a curve is y equals x squared minus 8x plus 5. Part A. Find the coordinates of the minimum point of the curve. So what we have here is a quadratic equation, and to get the minimum point or a turning point of the curve, we simply have to complete the square. So y is equal to x minus divide b by 2, so that's minus 4 squared. Minus 4 squared, which is minus 16, plus the 5, that's 5. So y is equal to x minus 4 squared minus 11, and therefore the coordinates of our minimum point would be 4, negative 11, and that's our final answer. The curve is stretched by a factor of 2 parallel to the y-axis and then translated by 4, 1. Part B. Find the coordinates of the minimum point of the transformed curve. Okay, so our curve from part A, we'll take it in its completed square form, is x minus 4 squared minus 11. And the first transformation that they apply is a stretch by stretch factor 2 in the y-axis. So let's apply that stretch. That's 2, and we're multiplying our whole function by 2 minus 4 squared minus 11. Let's simplify this. This is y is equal to 2 times x minus 4 squared minus 22. And then the second transformation they apply is translation by translation factor 4, 1. So that means this is y equals to x minus 4. If we translate by 4 units in the x direction, we write it as minus 4 inside the bracket, and then minus 22. In the y direction, we take the 1 as it is, so it's just plus 1. And if we simplify, that's y is equal to 2x minus 8 squared, and this is minus 21. So now if you are to read the coordinates of the minimum point, in this case the coordinates would be 8 and negative 21, and that would be our final answer. Part C. Find the equation of the transformed curve. Give the answer in the form y equals ax squared plus bx plus c, where a, b, and c are integers to be found. Okay, so let's take the completed square form of our answer in B. So that's y is equal to 2 times x minus 8 squared minus 21. And now we simply have to expand. So this will be y is equal to 2, and then we have a big bracket over here. That's x squared minus 16x plus 8 squared, which is 64, and minus 21. So y is equal to 2x squared minus 32x plus 128 minus 21, and therefore y is equal to 2x squared minus 32x plus 107. Number 7, part A. Verify the identity 2x minus 1 times 4x squared plus 2x minus 1 is identical to 8x cubed minus 4x plus 1. Okay, so let's start by multiplying 2x with this whole bracket over here. So that's 2x times 4x squared plus 2x times 2x minus 2x. And now let's multiply the minus 1 by the whole bracket. So that's minus 4x squared minus 2x plus 1. If we simplify this, that's 8x cubed plus 4x squared minus 2x minus 4x squared minus 2x plus 1. Okay, so 8x cubed remains as 8x cubed. The 4x squared will cancel with minus 4x squared. Minus 2x gives us minus 4x, and then we have plus 1, and therefore 2x minus 1 times 4x squared plus 2x minus 1 is in fact identical to 8x cubed minus 4x plus 1. Let's move on to part B. Prove the identity tan squared theta plus 1 over tan squared theta minus 1 is identical to 1 over 1 minus 2 cos squared theta. Okay, so for this identity, let's work from the left-hand side to the right-hand side. And the first step here would be to simplify tan theta using the identity tan theta is identical to sine theta over cos theta. In this case, our tan theta is squared, so it means we're also going to square those. So this becomes sine squared theta rather, over cos squared theta plus 1, and this is divided by sine squared theta over cos squared theta minus 1. And now we're going to combine these two to become one term. So put them under one common denominator. So that would be cos squared theta, and the numerator is sine squared theta plus cos squared theta. And you're going to do the same for your denominator. So that would be sine squared theta minus cos squared theta over cos squared theta. So here you notice that we can use the identity sine squared theta plus cos squared theta is identical to 1. So we can replace that part with 1. So it becomes 1 over cos squared theta. Now I'm just going to write it side by side so that it's a bit clearer. Divided by sine squared theta minus cos squared theta over cos squared theta. And now we can invert our fraction on the right hand side. So that's multiplied by cos squared theta over sine squared theta minus cos squared theta, and these will cancel out. So what you end up with is 1 over sine squared theta minus cos squared theta. And notice that we're trying to get to 2 cos squared theta. So we need to get rid of the sine squared theta over here. We can do that by saying that can be written as 1 minus cos squared theta, and then minus our cos squared theta over there. And if you simplify, what you end up with is 1 over 1 minus 2 cos squared theta, and you have proved your identity. Part C. Using the results of A and B, solve the equation tan squared theta plus 1 over tan squared theta minus 1 equals 4 cos theta. So they've emphasized that we're supposed to use both results from the earlier parts. So let's start by using the result from part B to simplify this. We proved that tan squared theta plus 1 over tan squared theta minus 1 can be written as 1 over 1 minus 2 cos squared theta. So it means that this equation they've given us can be written as 1 over 1 minus 2 cos squared theta is equal to 4 cos theta. So let's get rid of our denominator. This will be 1 is equal to 4 cos theta times 1 minus 2 cos squared theta. Expand the bracket. That's 4 cos theta minus 8 cos cubed theta. Let's put all the terms on one side. We get 8 cos cubed theta minus 4 cos theta plus 1 is equal to 0. Now you notice that this equation is very similar to the equation we had in part A. If we just go back to it, we were given that, I'll use a red pen, 2x minus 1 times 4x squared plus 2x minus 1 is identical to 8x cubed minus 4x plus 1. So if we go back, just to copy this, that's 2x minus 1 times 4x squared plus 2x minus 1. So we've got 8x cubed minus 4x plus 1 is equal to 2x minus 1 times 4x squared plus 2x minus 1. Let's just check that we copied the correct thing. It looks correct. Yes. So notice how x has simply been replaced by cos theta. So x here is now cos theta, but the equation is the same. This means that in our blue equation, we can simply factorize it to become 2x minus 1 except times 4x squared plus 2x minus 1, except where there's an x, you're going to write cos theta. So it becomes 2 cos theta minus 1 times 4 cos squared theta plus 2 cos theta minus 1 is equal to 0. And now we can equate each bracket to 0. So you've got 2 cos theta minus 1 is equal to 0. And then our quadratic 4 cos squared theta plus 2 cos theta minus 1 is equal to 0. So let's deal with the first equation. That's cos theta is equal to a half. This theta is equal to arc cos of a half. And theta is equal to, this is arc cos of 1 over 2, which gives us 1 over 3 pi. Let's just check if we're in radians or in degrees or in degrees. So I should give my answer in degrees instead of in radians. So I'm just going to change to degrees. So that would be 60 degrees. 60 degrees, and our interval is from 0 to 180 degrees. So we know that if we were to sketch our curve of y is equal to cos theta, this would be our curve over here. And so we've got the solution 60 degrees. Let's say 60 degrees is somewhere here. And we're told that we're ending at 180 degrees, so that's the only solution in the interval 0 to 180 degrees. This will be theta. So we have one solution which is theta is equal to 60 degrees. So let's deal with the quadratic now. Okay, so let's use the quadratic formula to solve this quadratic. So that's minus b, which is minus 2, plus or minus the square root of b squared, which is 2 squared, minus 4 times 4 times negative 1. And this is all over 2 times 4. So cos theta is equal to, let's punch this into a calculator, that's minus 2 plus the square root of 2 squared minus 4 by negative 1 over 2 times 4. And that gives us cos theta is equal to negative 1 plus or minus root 5 over 4. Okay, so we have two equations. Let's go down where we have a bit more space. So we've got cos theta is equal to negative 1 plus root 5 over 4. And we have cos theta is equal to negative 1 negative root 5 over 4. And let's work with our first equation. Theta is equal to arc cos of negative 1 plus root 5 over 4. And so theta is equal to, this is arc cos of negative 1 plus root 5 over 4. And that gives us exactly 72 degrees. And then we have theta is equal to arc cos of negative 1 negative root 5 over 4. And theta is equal to, so this is 144 degrees. So therefore the final answer would be theta is equal to 60 degrees, 72 degrees, and finally 144 degrees. Let's move on to question number 8. Functions f and g are defined by f of x is equal to x plus a squared minus a for x is less than or equal to negative a. G of x is equal to 2x minus 1 for x is an element of all real values. where a is a positive constant. Find an expression for f inverse of x. Okay, so we've got f of x, we'll write it as y is equal to x plus a squared minus a. So let's make x the subject of the formula to get our inverse of f of x. So we're going to add a to both sides, so y plus a is equal to x plus a squared. Take the square root of both sides, root y plus a is equal to x plus a. Remember that this is plus or minus, and then this becomes x is equal to negative a plus or minus the square root of y plus a. We need to pick a sign here. We use a rule of thumb that if the original function has a domain with a less than sign, we're going to take the negative function. If it had a positive sign, a greater than sign, would have taken the positive. So in this case, we're going to say that therefore f inverse of x is equal to negative a minus the square root of x plus a, and that's our inverse function. B part 1 states the domain of the function f inverse of x. So the domain of the inverse function is the range of the original function. So we know that our quadratic f of x, if we were to draw the graph of y equals f of x, we are looking at a curve that's something like this. And then we have our minimum point being at negative a, negative a. So our coordinates here would be negative a, negative a. So if we want the range of this function, we can see it's increasing going upwards. So the range of f of x would be f of x is greater than or equal to, because of that sign over there, negative a. So it means that our domain for the inverse function would be x is greater than or equal to negative a. So our domain here is x is greater than or equal to negative a, and the range of the inverse function, part 2, state the range of the inverse function, is the domain of the original function. So that's x is less than or equal to negative a. So our final answer here would be f inverse of x is less than or equal to negative a. Part C, given that a is equal to 7 over 2, so the equation g f of x is equal to 0. Okay, so we had f of x being equal to x plus a squared minus a, and g of x is, our g of x is 2x minus 1. Okay, gx is 2x minus 1. So we're putting f of x into g. So g f of x is equal to 2 times, we're putting this whole function here, x plus a squared minus a minus 1. And so this simplifies. If we expand, that's 2x plus a squared minus 2a minus 1. This is our g f of x, and we're equating it to 0. And then we're given that, or rather before we equate to 0, we're given that a is 7 over 2. So let's substitute a with 7 over 2. So that's x plus 7 over 2 squared minus 2 times 7 over 2 minus 1. And so you end up with 2x plus 7 over 2 squared minus 7 minus 1, which is 2x plus 7 over 2 squared minus 8. And this is g f of x. And now we can equate it to 0. So 2 times x plus 7 over 2 squared minus 8 is equal to 0. And let's solve for x. So that's 2 times x plus 7 over 2 squared is equal to 8. Divide both sides by 2. X plus 7 over 2 squared is equal to 4. Take the square root of both sides. X plus 7 over 2 is equal to plus or minus 2. And x is equal to negative 7 over 2 plus or minus 2. And so x is equal to, so we have negative 7 over 2 minus 2, which would be negative 5.5. And we've got negative 7 over 2 plus negative 1. That would be negative 1.5. And now we need to check if both of these values satisfy our domains. So we're given that x, for f of x, x must be less than or equal to negative a. And in this case, our a was given as 7 over 2. Let me just clarify that. Yes, a is 7 over 2. So this is the same as x is less than or equal to negative 3.5. Let's go back to our solutions. So we know that x should be less than or equal to negative 3.5. So that means we're going to disregard that solution and we're going to take x is negative 5.5, and that's our final answer. Number 9. The diagram shows the curves with equations y equals 2x to the power half plus 13x to the power minus half, and y is equal to 3x to the power minus half plus 12. The curves intersect at points A and B. Find the coordinates of A and B. Okay, so since the curves are intersecting at A and B, we can get their coordinates by solving the two equations simultaneously. So what we can do, we can equate the two equations. So it's 2x to the half plus 13x to the negative half is equal to 3x to the negative half plus 12. So let's make our powers positive because it can get very complicated if we work with negative powers. So that's plus 13 over root x is equal to 3 over is equal to 0. So this is 2x minus 12. Let's rewrite this as x to the power half, which I'll explain in a minute, plus 10 is equal to 0. So what we have here is a hidden quadratic. And to show you that, I'm going to write it as 2. Then we've got x to the power half squared minus 12x to the power half plus 10 is equal to 0. So you can see that now our equation is in the form ax squared plus bx plus c is equal to 0. So in this case, our x is being represented by x to the power half, right? So now we need to solve our hidden quadratic. But first, let's just divide through by 2 to simplify. So what you have is x to the power half, and that's squared, minus, if you divide 12 by 2, you get 6x to the power half. And then that's plus 5 is equal to 0. Let's factorize this. That's x to the power half. And that would be minus 5 times x to the power half minus 1 is equal to 0. So if you're not comfortable with solving hidden quadratics like this, feel free to substitute. For example, you can say let y equals x to the power half. So what you then end up with is a quadratic in the form y squared minus 6y plus 5 equals 0. And you can always solve the quadratic and then come back to x to the power half and solve for x. Oh, we've run out of space. So we have, this will be x to the power half is equal to 5. From this bracket, x to the power half is equal to 5. And you've got x to the power half is equal to 1. So square both sides to evaluate x. So that would be x is equal to 5 squared, which is 25. And then x here, if we square both sides, is equal to 1. Get x is 1. And we want the coordinates of a and b, so we also have to evaluate the y coordinates since we have the x coordinates. We've got y is equal to 3x to the minus half plus 12. So let's evaluate at x is equal to 25. So y would be 3 times 25 to the power negative half plus 12. Punch that into the calculator. This is 3 times 25 to the power negative half plus 12. And that gives us 63 over 5. And then let's evaluate at x is equal to 1. At x is equal to 1, this would be y is equal to 3 times 1 to the negative half plus 12. This would simplify to give us, that's 15. And so it means the coordinates of a and b, let's check which one comes first. So a comes first, so it means a would have the coordinates 1, 15. And then b would have the coordinates 25 and 63 over 5. Let's move on to part B. Hence find the area of the shaded region. Okay. So to get our shaded region, we're going to integrate. So we're going to say the curve that's on top minus the curve that's on the bottom. And our limits would be at a, which is 1, and b, which is 25. Okay. So this is the integral from 1 to 25 of our upper curve. Our upper curve is 3x to the negative half plus 12. 3x to the negative half plus 12 minus the lower curve is 2x to the half plus 13x. 2x to the half plus 13x to the negative half. And this is all with respect to x. Let's just expand our bracket first. So this would be the integral from 1 to 25 of 3x minus half plus 12 minus 2x to the half. And that would be minus 13x to the negative half. With respect to x, if you simplify like terms, we end up with, this is 25. So that's 3 minus 13, that was minus 10, x to the negative half, minus 2x to the half, and then we've got a plus 12 with respect to x. Now we can integrate. So if you add 1 to negative half, you get half. So that's negative 10 over half, which is negative 20x to the power half. Add 1 to half, you get 3 over 2. So that's negative 4/3. And this is 6 to the 3 over 2 plus 12x. And our limits are 1 to 25. Okay. So now let's substitute in our limits. Got negative 20. That's 25 to the power half minus 4/3 and this would be 25 to the power 3 over 2 plus this is 12 times 25, and then we're going to subtract the lower limit. That would be negative 20 times 1 to the power half minus 4 over 3, 1 to the 3 over 2 plus 12 times 1. We'll close this bracket. Let's simplify the first bracket. If you punch that into your calculator, you get negative 20 times 25 to the power half minus 4 over 3 times 25 to the power 3 over 2, and that's plus 12 times 25, so that gives us 100 over 3 minus, let's substitute x with 1. So if you substitute x with 1, you should be getting negative 28 over 3. So that's negative 28 over 3. So this is 100 plus 28 over 3, which is 128 over 3, and that would be our final answer. Therefore, the area is equal to 128 over 3. Number 10. The equation of a curve is y equals f of x, where f of x is equal to 4x minus 3 to the power 5 over 3 minus 20 over 3x. Part A. Find the x-coordinates of the stationary points of the curve and determine their nature. Okay, so let's start by finding f prime of x, which is our first derivative. And so if you bring down the power here, that's 5 over 3. 4x minus 3, subtract 1 from the power, that will give us 2/3, and then multiply by the 4. And now if you differentiate negative 20/3 x, you get negative 20/3. If we simplify this, f prime of x is equal to 5 over 3 by 4 gives us 20 over 3, and this is 4x minus 3 to the power 2 over 3 minus 20 over 3, and this is our first derivative. Now we want to find the coordinates of the stationary points of the curve, so we're going to equate it to 0. So 20 over 3 times 4x minus 3 to the power 2/3 minus 20/3 is equal to 0. And so multiply through by 3 over 20. So what you end up with is 4x minus 3 to the power 2/3 minus 1 is equal to 0. And now we need to solve for x. So this is 4x minus 3 to the power 2 cubed is equal to 1. Okay, so now let's multiply both sides by the power 3. And this is 1 to the 3, so that these threes cancel out, and you end up with 4x minus 3 squared is equal to 1. And then take the square root of both sides, so you have 4x minus 3 is equal to plus or minus 1. 4x is equal to 3 plus or minus 1. X is equal to 3 plus or minus 1 all over 4. So our two x coordinates would be 3 minus 1 over 4, which is a half, or 3 plus 1 over 4, which is 1. And what else do they want us to find? The nature of these stationary points. So that means we have to find our second derivative, f prime prime of x. And our first derivative is, here's our first derivative. So if we drop that power, it would be 40 over 9 times 4x minus 3. This is to the power 2/3 minus 1, which would be minus 1 over 3. and then the minus 20 over 3 becomes 0. So this is our second derivative. Now let's evaluate it at x is equal to a half. Okay, so let's substitute x is equal to half into our second derivative. So this is f prime prime of half is equal to 40 over 9 times 4 bracket half minus 3 to the power negative 1 over 3. Let's punch this into the calculator. That's 40 over 9 times 4 times half minus 3 to the power negative 1 over 3, and that's negative 40 over 9. And so that will mean this is a maximum point. Let's evaluate the other point. That's f prime prime of 1, and that's 40 over 9. 4 times 1 minus 3 to the power negative 1 over 3. And if we substitute x with 1, we get 40 over 9. So this would be a minimum point. So therefore, at x is equal to half, f prime prime of x is less than 0, hence maximum point. And then at x is equal to 1, f prime prime of x is greater than 0, hence minimum point. And that's all for part A. Let's move on to part B. State the set of values for which the function f is increasing. For a function to be increasing, or for a function to be an increasing function, the gradient dy dx should be greater than 0. So in this case, let's look for our gradient function, which should be f prime of x is equal to so that's f prime of x is equal to 20 over 3 times 4x minus 3 to the power 2 over 3 minus 20 over 3. So 20 over 3. 4x minus was 4x minus 3 to the power 2/3 minus 20 over 3. And so we're saying for our function f to be an increasing function, f prime of x should be greater than 0. So we need to solve this inequality. Instead of solving the whole thing, I'll just go back. There's a point when we were solving f prime of x is equal to 0, and we're finding our stationary points. Now we're just simply solving f prime of x is greater than 0. So we can come to this point over here, and we're only going to replace this equal sign with the greater than sign. So what we have is 4x minus 3 squared is greater than, was it 1? Yes, it was 1. So it's greater than 1. So you notice that this is a quadratic inequality. And if you have a quadratic inequality, first you have to find the roots, and then you find the required region. So in this case, the roots, if you solve this equation, which we already did when we solved f prime of x is equal to 0, the roots that you get are x is equal to half and x is equal to 1. And then we know that our curve is an open U-shaped graph. And at this point, that would be half. And at that point, that will be 1. And we want the greater than region. So the region that's above the x-axis. And so we have 2 of those regions. So that's x is less than half and x is greater than 1. So what this means is that f prime of x is our gradient function, and this gradient function is above the x-axis when x is less than half and when x is greater than 1. When it is above the x-axis, it is positive. The function is increasing. So this would be our final answer. Number 11. The coordinates of point A, B, and C are 6, 4, P, 7, and 14, 18 respectively, where P is a constant. The line AB is perpendicular to the line BC. Given that P is less than 10, find the value of P. Okay, so let's try to sketch a diagram of our problem. It's not going to be an exact sketch. So we'd have A, let's say A is somewhere over here. And then we'd have B being somewhere over here. This is B, and then we need C. C is 14, 18, so we'll say somewhere here. That will be C. And we're told that BC is perpendicular to AB. Okay, so if we rejoin the points A and B, and then the points B and C, and these lines should be perpendicular. Now we have to find the value of P. So what do we know about perpendicular lines? We know that M1 times M2 is equal to -1. So let's find the gradient of BC. So the gradient of BC would be, in this case, that's 7 minus 18. So 7 minus 18, and that is divided by P minus 14. P minus 14, and this is being multiplied by M2, which is the gradient of A and B. So that's 4 minus 7, 4 minus 7 over 6 minus P, 6 minus P, and this is all equal to -1. So 7 minus 18, that's minus 11 over P minus 14, times 4 minus 7, that's minus 3 over 6 minus P is equal to -1, -11, and this will give us -11 times -3, which is 33 all over P minus 14 times 6 minus P is equal to -1. We can write this as 33 is equal to negative P minus 14, 6 minus P. Let's expand our brackets on the right hand side. So we get negative P squared. Then we've got 6P plus 14P, which is 20P. And then finally we have 14 times 6, negative 14 times 6. So that gives us -84. And let's just expand that bracket again. So that's P squared minus 20P plus 84. Let's put all the terms on one side. P squared minus 20P plus 84 minus 33 is equal to 0. So P squared minus 20P plus 51 is equal to 0. And if we factorize our quadratic, that's P minus 17 and P minus 3 is equal to 0. So you get P is equal to 17 or P is equal to 3. And the question tells us that P is less than 10. So we can conclude that therefore P is equal to 3. Let's move on to part B. A circle passes through the points A, B, and C. Find the equation of the circle. Okay, so we have our circle. Bear with me, it's not a perfect circle. But we have our point. This is point C. And I think somewhere here we've got point B. And we should have point A over here. And then if we are to draw a line, that's A, then that's B, that's C. We have a right angle here since BC is perpendicular to AB. Then our center of the circle should be the midpoint of AC. If you remember, there's a circle theorem that states that a triangle in a semicircle has a 90-degree angle. So that should mean that our 90-degree angle is here. So that should mean the midpoint of this line AC must be the center of our circle that has the points A, B, and C on the circumference. So using this knowledge, we can then say that the center of the circle is the midpoint of AC, and we can find our midpoint using the coordinates of A and C. The coordinates of A are 6, 4, and C is 14, 18. So A has coordinates 6, 4, and then C is 14, 18. So we can say x, that's 6 plus 14 over 2, and then y would be 4 plus 18 over 2. And so you get m as the coordinates 20 over 2, which is 10, and then 22 over 2, which is 11. So the coordinates of our center are 10, 11. And now we also need to find the length of the radius. And to do that, we can say that our center has coordinates 10, 11, and we know that A is 6, 4. So the radius is the distance from A to the center. And so we can say that our radius is equal to the square root of, we can do 10 minus 6 squared plus 11 minus 4 squared. Punch this into the calculator. This is the square root of 10 minus 6 squared plus 11 minus 4 squared, and you get root 65. And so the equation of the circle would be x minus 10 squared plus y minus 11 squared is equal to r squared, which is 65. And this would be our final answer. Part C. Find the equation of the tangent to the circle at C given the answer in the form dx plus ey plus f is equal to 0. Okay, so if we draw a circle again, point C was somewhere here, and then with our center here being 10, 11, and then this is C. We have our tangent at C, and we want the equation of this tangent. We know that it forms a right angled triangle over here. So to get the equation of a line, we need a gradient and a point. We already have the point C, which is coordinates 14, 18. So now we need the gradient. Since the tangent is perpendicular to the radius, we can find the gradient of our radius from the center to C. So that would be 18 minus 11 over 14 minus 10. And that's 18 minus 11, that's 7 over 14 minus 10, which is 4. And so the gradient of the tangent, M tangent, is the negative reciprocal, so that's negative 4 over 7. And now we can use y equals mx plus c, and y is 18, which is equal to the gradient negative 4 over 7 times x, which is 14, plus c. So you get 18 is equal to negative 4 over 7 times 14, which is negative 4 times 2, negative 8. Negative 8 plus c, so c is equal to 26. And so we can write our equation as y is equal to negative 4 over 7x plus 26. Now notice that they've given the equation in the form dx plus ey plus f is equal to 0. So it means we need to get rid of the denominator. So multiply through by 7. You get 7y is equal to negative 4x plus 26 times 7, which is 182. And then put all the terms on one side. So you've got 4x plus 7y minus 182 is equal to 0. And this would be the final answer. And that was the last question. So that's all for this paper. If you enjoyed this, please subscribe for more videos like this and comment down below which paper would you like to see me break down next. Bye bye.